what if this new life form catches fire, quote unquote, and becomes alive and it's a new species? Is that a concern?
Wow. Okay, that would be insanely awful if that happened. Yeah, that would be terrible. It's not a concern for me right now just because the Venus environment is so different, but it's certainly something. There is a NASA office called Planetary Protection, and that means that missions we send to other planets have to be sterile to protect that planet, but it also involves sample return and how we have to be ultra careful so nothing bad happens. But we haven't put enough thought into that, only that the environment is so different it's kind of unlikely that life could survive here, but it's certainly a concern people have.
Hello everyone, and welcome to this very special edition of Through Conversations podcast, where we explore the truth through conversations with the most brilliant minds. And today, joining me is Professor Sara Seager. Professor, thank you so much for joining me today.
Thanks for having me today.
I'm honored, and it's a special day for me because we're going to explore one of the most asked for topics in the podcast by our community, life out there, the life out there, searching life out there. And you're in the forefront of that, finding exoplanets and possible habitable planets out there. But let's start with your work, Professor. In your work on Venus Life Finder, you found microbial life, or you found some hints into potential life in the atmosphere of Venus. Would you like to share with our audience what does this mean for life out there, and also like your work around Venus?
Yes, well, in the search for life beyond Earth, one of the key things astronomers have been thinking about for nearly a century is detecting gases in the atmosphere that don't belong. Like here on Earth, we have oxygen. That fills our atmosphere to 20% by volume that we all need to breathe. But without life, without plants or photosynthetic bacteria, there'd be no oxygen in our atmosphere. It's so reactive, it shouldn't be there at all unless it's being replenished. So this idea of looking for a gas that doesn't belong, that's so reactive it shouldn't be there unless replenished, is one we've had for a long time. Well, I was part of a team that reported the detection of a gas in the Venus atmosphere in 2020, the year 2020, a gas that didn't belong, that is very reactive, that doesn't appear to be made by lightning or volcanoes or meteoritic delivery or anything really. And it left the kind of remote but still possibility that there might be life. So we didn't say there's life, we didn't find life. It was just this hint of like a gas that we reported detecting that might indicate life. But that was very controversial. It's definitely not accepted all around, and it's part of the back and forth of science to see where this particular detection goes.
And why the controversy? Why not the excitement? Why not just the embrace of the scientific community and the public as a whole? I myself, before getting to know your work, and especially during 2020, I think all of our attention was scattered throughout. But why the backlash?
Well, it's a really good question. And I think it helps for two things. One, to show how science is done. And the other, how to embrace crazy ideas. We have this thing in science we call the giggle factor. Like, do you ever have someone who comes up to you and tells you, hey, I'm going to go to the moon. Hey, I'm going to go to Mars, or something so silly that you have to really try hard to not laugh at them. Or maybe you do laugh.
This
Do you have that?
To me on a daily basis with my own ideas, Professor.
So you put your own ideas to someone, they just laugh. Yeah.
Yeah.
Yeah, we call it the giggle factor. And the question is, can your idea pass the giggle factor or not? And the idea of life on Venus does not pass the giggle factor. Because, first of all, the surface of Venus is too hot for life of any kind. Venus has a massive carbon dioxide greenhouse atmosphere. But just like on Earth, if you hike up a mountain or go in an airplane, it gets colder and colder above the surface. And on Venus, 50 kilometers above the surface, it is the right temperature for life. Wow. And yeah, this is why over half a century ago, Carl Sagan put out the idea that maybe there's life in the clouds of Venus. There's life in Earth's clouds. Bacteria get swept up and they float around for a while in the clouds, in the cloud particles before getting rained out. So it kind of seems like it might be a good idea, but at the time they didn't know the clouds aren't made of water. They're made of a very harsh, nasty chemical called sulfuric acid. You might not have used it before. I don't know, like the older generation, you know how they had fewer rules and people didn't worry so much. If you talk to someone older, they're like, yeah, I know what that is. Wow, it's so dangerous. I've gotten hurt or something.
It reminds me, I don't know if this is, I'm completely confused, but is it like, do we see this acid in rain, in polluted areas, or am I just off?
Oh, right. Yeah, so back in the 80s, there was acid rain that killed life inside lakes and stuff. That was not acid like this kind of acid. That was water with a bit of acid in it. We're talking about like pure acid, something we don't have naturally on Earth. You know, we do have very acidic environments, but the clouds of Venus and the level of acid, the level of acidity, it's like many orders of magnitude higher than anything on Earth. So it is similar, but it's like a whole other level. So the fact that the acidic clouds, that level of acid kills all of our life, that's why there's the giggle factor about life on Venus. So the first reason people were so skeptical was it makes absolutely no sense that there could be life there. But let's switch now to the scientific reason people got upset.
Yeah.
That our data here on Earth, the data we take with telescopes, because most of them are taxpayer funded, the data becomes publicly available, which is fair, to see if, you know, other people can use the data if they want to, if they know how to, and see if they can replicate your experiment. So people immediately went to analyze the data, and the majority of people did not recover the signal in the data. So the first question we have to ask ourselves, is the signal real? And a lot of people don't think the signal is real. Some people did, well, I'll let you respond to that, because some people did recover the signal. So a smaller fraction of people did recover the signal and do agree the signal is real. But that's the first problem.
I guess my question here is, and also while reading your work and your research, is how are we retrieving these signals? Is it through a computer? Is it through satellites? How do we retrieve those samples back to Earth?
In this case, we took the data with radio telescopes. So large radio telescopes. One is on top of Mauna Kea in Hawaii. It's called JCMT, James Clerk Maxwell Telescope. The other telescope array is called ALMA, Atacama Large Millimeter Array in Chile. And these are high on mountains to get away from the water vapor that plagues our lower atmosphere. So we take the data, but there's always something from taking the data to analyzing the data. And in particular, you have to remove parts of the data that aren't from the signal. Like Venus is very bright and the light scatters off of different parts of the telescope. And you don't want that. That's not part of your signal. So a sign of life or a signal at the forefront could be very, very tiny. And so you definitely have to do a lot to the data to pull that signal out. So, okay. Yes, so the data is coming from large ground-based observatories, and it's not like just snapping a photo and saying, okay, yeah, there's my signal. In the best case scenario, it would be simple. But for tiny signals, you have to work with the data. I don't want to say Photoshop, but that might be the simplest thing that makes sense to you. Like you might take a picture and you're playing around with the contrast. Maybe you're cropping the photo. So it's data analysis to draw the signal out.
And Professor, based on these findings, do you believe that it's called phosphine, right? Phosphine.
Phosphine gas, right?
Phosphine gas. So
yeah.
Go ahead.
Right. Well, I wanted to just walk you through the three reasons why people didn't believe it. So the first was, is the signal real? And, we can come back to these three criteria later on in the conversation if we switch topics. So one, is the signal real? Two, if the signal is real, is it attributed to the right gas? So we claim there is a real signal, and it's from phosphine gas, a gas that most people have never heard of because it's a very unusual gas here on Earth. It only occurs by us humans making the gas as a pesticide or a toxin of some kind, or life in oxygen-free environments like bacteria in swamps or places where there's no oxygen. So phosphine is a very unusual gas. It shouldn't be here because it's very hard to make. And that's true on Venus as well. But some groups who did recover the signal and believe the signal is real said it's not phosphine. This signal is produced by a different gas. They wanted to say it was produced by a different gas, one that's known to be on Venus called sulfur dioxide. So that was the second issue. And the final issue was, let's say you agreed that the signal is real, that it's attributed correctly to phosphine. Then the question is it made by life or is it made by a non-life source? And that's a very hard one to answer for a planet far away. But we went through all the chemistry that we know about, and we wrote 100 pages, and we just said, look, it's not possible for it to be anything any chemical pathway we know about. Like I said, volcanoes or lightning or anything else. But there was skepticism at all those three levels. Is the signal real? Is the signal attributed to the right gas? And if the signal is attributed to the right gas, what is the source, life or non-life? Do you see why it's so hard? I hope I've helped share with you why it's not just like so simple.
Yes, of course. No, I can imagine that this is one of the hardest and most controversial questions that we're trying to solve. I guess that my curiosity then goes into, probably it's tangential to the third point, which is it a non-life or a life source? It relates to the idea of it being directly sourced from Venus. Like, is it a natural component of Venus, or did it emerge from, an asteroid or something, just like stardust just scattering throughout the galaxy?
Right. Well, that's one of the things we looked into in our 100 pages. Because Earth and Venus and other planets, they're receiving this meteorite dust, we could call it. Lots of it, actually. And knowing what those meteorites are made of, you can make a calculation that says what is, if there's phosphorus compounds in there, could they turn into phosphine? And in many of these cases, the answer is maybe, but in such tiny amounts, it could never explain the amount that we have found. So all these are viable possibilities, and we scientists make calculations to see whether it pans out or not.
And that brings me to the contrast between life on Earth, the diversity of life here, and not finding that elsewhere, not even on Venus, even though, there's hints to it. The question here is, and it also relates to another point, which is the Goldilocks zone, which I would love for you to expand on. What does it mean for finding life out there on exoplanets? But did the Earth become just like an attractor of this stardust, of these life-creating chemicals, and just compiled everything together, whereas other planets weren't just that lucky? Or why is it that we can't find... We can just... It's just like we're like a crime scene investigator trying to find, the pieces of the puzzle, and they're so scattered throughout the entire galaxy, and we still don't find anything as concrete as planet Earth, if that makes sense.
Right. It's a really good question. Now, there could be life on Venus still. It could be making phosphine. It could not be making phosphine, because we think that life needs a few criteria: a liquid environment, so molecules can react and reactions can get carried out. Venus has that. It has liquid cloud particles. They're just acid, not water. We think life needs the right temperature so that complex molecules can form. Venus has that. And life needs an energy source, and Venus has that, the sun. But if there is life, why is it so hard to find? Because, Venus is starved in terms of its resources. Imagine if there's life in the clouds. It doesn't have, like you were saying, the lush forest or oceans or land runoff. If there is life, it's like barely eking out an existence up there. Imagine that the cells are there living, but they're barely doing anything. It's like worse than a hibernating animal. Like, it wouldn't barely be doing anything. And so it's also not outputting gases or giving a lot of signs. But we do feel that if we could go to Venus and investigate, we could send a balloon to Venus' atmosphere, and we could look at suck in the cloud particles and subject them to special chemical analyzers. We might find signs of life. We might find very complex molecules only associated with life. But if there is life, we're thinking of a very, very primitive type of cell that's just barely eking out an existence and not really easy to find from far away. So that does relate to your second question, is why is Earth so good? We just think we won the lottery of planet formation. Because we see stars with planet-forming disks, like a star is born and it's got a lot of leftover gas and dust swirling around it that we have evidence forms the planets that we see today. But where a planet forms and how big that planet becomes, we don't fully understand that, and we think some of it is just random. Like, I don't know if you have this, but we get dust bunnies under the bed, under the couch. Dust collects and it starts forming like little patches of dust. But why did that form under the left side of your couch instead of the right side? Or, what? It's just, maybe you didn't vacuum properly. But in the disk, why does one part start collecting more than another part and then growing to form a planet? So we got lucky here that Earth formed and is the right distance from our sun, that with its atmosphere and greenhouse gases, it had the right surface temperature for liquid water. Some people think that both Venus and Mars also formed with liquid water, like surface oceans, but that through time they lost them, that Venus became too hot and the water essentially boiled away. So it's largely just a matter of luck.
Wow. We should definitely cover that idea we got lucky after in our conversation when we get into the philosophical realm of things. But I'm very curious because mainstream media or mainstream science or, the topic of conversation is always Mars. We need to go to Mars. We have to create, a habitable planet there on Mars. We should explore first the viability of getting into Mars and not always about, we don't hear about Venus that much, at least, in the mainstream. So do you think that going into Mars versus Venus, is it a mutually exclusive endeavor, or could we go on both planets at the same time?
We should definitely do both. There are still limited sources of money to get to both, but I always think of Venus as the neglected sibling. Earth, Mars, and Venus. I don't know if you have siblings or siblings. Yeah. Do you know how one sibling gets all the attention?
Yeah.
And the other one's usually ignored? Yeah.
Yeah. In my case, it was because my older brother, he was failing in school, so he got most of the attention on that front. But it varies, it ebbs and flows.
Okay. Well, I hope it's going to ebb and flow with the siblings of our solar system, because so far Mars is the one that gets all the attention. And Venus has been, quite ignored, actually. And so Venus is like that special sibling who just no one really bothers with, but has a lot to offer. So one thing the Phosphine report did, despite all the controversy, it definitely brought more attention to Venus. And now there's a few missions being planned to go to Venus. But one thing it did was it actually gave me a new purpose and my team. And what we've been doing is we've been studying sulfuric acid, concentrated sulfuric acid, what the clouds of Venus are made of, and we've been studying them in a laboratory setting. Because people assume that sulfuric acid, because it kills all of our life, that nothing could survive. But what we did was, for example, we took some chemicals, our 20 amino acids. Amino acids, you can buy a whole kit of them from like Walmart. People eat them, actually, bodybuilders. Yeah. So we had to buy a higher grade. We couldn't just get the one from Walmart because they weren't pure enough. But we bought a kit of all the amino acids and we put them in sulfuric acid. And wow, with one exception, they are stable in sulfuric acid. They're not ripped apart or anything. Some of them are chemically modified by the acid, but then they are stable. And we tried this with other biomolecules. So although our life can't survive, our Earth life, some of our biomolecules can survive. And it's enough to let us imagine that another type of life, like with a different type of DNA, different type of proteins, could survive in these sulfuric acid clouds. So we're building the case that there could be life. Not that there is life on Venus, but there could be life based on complex molecules in concentrated sulfuric acid. And we're trying to motivate the case for going back to Venus to specifically search for signs of life. Remember the giggle factor? It's too crazy for NASA and ESA and other large government agencies to go to Venus to look for life, but it might be just legit enough that we can rally private funding to go back there.
And, you mentioned the word complex life.
Complex chemicals. Simple life, complex chemicals.
So when it comes to simple life, if this form of life does have the ability to survive on such harsh environments, could we make the case that it's more advanced than life on Earth?
No, I don't think so. Because it's so simple, we can't really expect complex life in such a resource-starved place.
And if we would be, if this podcast really gets to everyone who wants to fundraise space missions. I remember a movie, I don't remember the name, but there was a movie where they bring back a sample of another planet, and then this sample of simple life, since Earth is so, so great in terms of the Goldilocks zone and all of the aspects of it that you just mentioned in terms of what makes life thrive, what if this new life form catches fire, quote unquote, and becomes alive and it's a new species? Is that a concern, or?
Wow. Okay, that would be insanely awful if that happened. Yeah, that would be terrible. It's not a concern for me right now, just because the Venus environment is so different. But it's certainly something. There is a NASA office called Planetary Protection. And that means that missions we send to other planets have to be sterile to protect that planet, but it also involves sample return and how we have to be ultra careful so nothing bad happens. But we haven't put enough thought into that. Only that the environment is so different, it's kind of unlikely that life could survive here. But it's certainly a concern people have. I mean, they're not imagining the full horror story that is. But it's definitely a problem, like the invasive species. There's this, I was just reading yesterday about this amazing, glorious tree called the American chestnut tree, a majestic species. And it was just wiped out in the early 1900s because of an invasive species from another continent. Just got in and, in just a couple decades destroyed it. So, yeah, never say never, let's just say.
This, I think it's a perfect segue into getting more into the depths into, going to Mars. I think I've never heard about planet protection, so I'm going to do research on it as well, because I'm very curious to, this is a judgment, this is not a fact, but at least I'm noticing that our current social fabric, social reality is kind of going into, I wouldn't say chaos, but we're facing a lot of challenges from everywhere, like socially, economically, and the climate change, a lot of threats, you could say, and challenges. And so, and on the other hand, we also have this possibility of going into other planets or finding life out there. And perhaps, some thought leaders argue that we should hedge existential threats here on Earth and going to Mars, so we become an interplanetary species and humanity survives. And then the concern here goes into my previous question and what you just mentioned, Professor, which is, quote-unquote invasive species. How can we ensure, if we go out there to other planets, how can we ensure that we bring the better angels of our nature? We just create good things for that planet and not just, replicate what we don't want to see here on Earth.
Well, that is super challenging, and we don't know how people will behave under very stressful conditions. Someone here who appears to be the right person may be the wrong person in that kind of stressful situation. But it is a bit of a dream because we know how hard the Martian environment would be. Like, we all really need oxygen to breathe. And there's no oxygen on Mars. And it would be really, remember the Venus life eking out the existence, kind of barely getting by? That would be us, really. I mean, we'd be having to live in caves with artificial air created that we could breathe, and it'd be very, very hard to raise crops. So in that sense, it's not fair to think about another planet as being a solution to our overpopulation and misuse of Earth. There's that, right? I mean, it always seems like there's an easy solution, but it will be very hard for us to live on Mars. That said, you can think about how far our human society has come in 100 years and 200 years and 300 years, right? So maybe in a few hundred more years, people want to go to Mars and terraform Mars to literally, that's just not like adding a few parts per million of carbon dioxide. They want to melt the ice caps and make a greenhouse atmosphere to warm the planet and then find a way to make oxygen. So I don't know if in your mind that would be being a good steward or a really bad steward of Mars. Good in that you could make it a place where people might be able to live more freely than in underground caves, but bad in that you've not protected the native planet as you've kind of done the opposite.
Yeah. And there are some hints that the way we can terraform Mars is through nuking Mars. So that would be a completely new, what if, like, how would we react to nuking Mars for it to, it's just such a paradox, right? It's the most destructive thing we've created, but it's the one that can potentially bring life in other planets.
Yeah, it's definitely a paradox. But I do want to get back to the sense that we love science fiction. We all love the idea of boots on Mars. But the reality is that any project on Mars would be so expensive and so energy consuming that we'd be better off applying that money and energy and thought to our own planet. But I mean, I'm with you on why people love dreaming about it, because it's an escape. Well, let me ask you this. Would you go to Mars given the chance?
At this stage where it is, I think that those who say yes, they know it's a one-way ticket. And I think there's a list of, I don't know, I'm making this up. Hopefully my team is going to fact check me after the edition of this. But I think it's several hundred or thousand of people who said, yes, I'm okay doing a one-way ticket. At this stage of my life, I think I have more to offer on Earth than on Mars. So I'm staying here. And that brings me to this whole idea that, we're so concerned of what's happening out there in terms of let's find Earth 2.0 that maybe we're missing out on solving our biggest challenges here. But at the same time, this is also something really intriguing because, and it's a question for you, Professor, but what's your guiding factor? What's your North Star in terms of finding Earth 2.0? Is it for us to just find, if I would realize that there's another habitable planet and maybe potentially life out there, I wouldn't feel, we feel that Earth is the lottery. We won the lottery and we're sacred and we need to value that. But at the same time, if there's other species out there, the loneliness factor of being on this weird universe reduces. So if I'm going to summarize my question is, what's the North Star of finding Earth 2.0 or life out there for you, Professor?
For me personally, it's just part of knowing what lies beyond Earth, what is out there, and is anyone out there? It's this idea that all of our daily problems and trials and tribulations are right here on this tiny planet. Our daily life is not always good. But that is really dwarfed by the vastness of the universe. And this idea that we finally have the ability to find other planets and to know if any of them are like Earth and eventually to find signs of life on them, I just do it out of pure inspiration and the desire to know if we're alone. But I definitely wanted to back up a bit because we do often get asked, why are we doing this? Like, why should we bother? Our own Earth is in peril. Why do we have the time and money to even devote to these things? Well, first, I can assure you it's just a small fraction of people's money and time in general. But as a civilized society, we do have to ask ourselves, should we have great art and music? And should we let our curiosity play a role in our daily lives? And the answer is a resounding yes. But sometimes by exploring random things, it leads us to other discoveries that once in a while do have a practical value on Earth. And it's hard to encapsulate that pure science can sometimes lead to a very useful tool. We don't necessarily need to go there, but I'll just mention one that I really like. It's our GPS. Like, don't you think every single person uses their phone to navigate?
All of us.
All of us do. But do you think someone said, hey, one day we're going to have phones and everyone's going to have like literally a computer they can carry in their pocket and we're going to need to find our way around? So, okay, I just remember when my dad, he's not alive now, but he was always the first to adopt anything. And he had this navigation system in his car. And I was like, this is ridiculous, because he couldn't find his own way around his city, Toronto. That's my hometown, Toronto, Canada. He relied on, because he had a very bad memory and a poor sense of direction. I inherited that too, but so he relied on this. He had no idea how to get around the city he'd lived in for decades. I just thought it was bad. But of course, everyone does that now. But do you think someone was like, hey, we're going to need a navigation system? No, people just wanted to play with rockets and see if we could launch rockets. And that eventually led to having satellites we can use to figure out where we are. And astronomy does have a few wins, actually. So we're trying to find life elsewhere. We're the branch that has a luxury job of being able to follow our curiosity. But at the same time, once in a while, it brings something useful back here.
Listen, I'm going to recommend you a book, if I may, Professor, because I completely subscribe to what you just said. The book is called Why Greatness Cannot Be Planned, and it's about two authors, Kenneth and Joel, the first name. They essentially make the case that AI just showed them that, and it's about life path itself as well. Like, it's not just about scientific discovery, but it's about, if we find an end goal, if we always look for the end goal, trying to reach our objective in life, we may be missing out on those stepping stones towards inventions like the one you just said, like the GPS. So, for example, how jazz was created. It was a blend of, people just figuring out how to play new songs. It wasn't just with the end goal of trying to create jazz or the computer. So I strongly recommend to you that book, and for our listeners as well. And because, like you say, and by the way, I would say we should fund more your endeavors, because curiosity is the fuel that drives new inventions. This podcast was born out of my curiosity, nothing else. So I completely subscribe to that. And going back into your first part of your intervention was that, the big if we find life out there, if we do find an exoplanet right now, based on correct me if I'm wrong, but based on the research, you have found 187 planets in the habitable zone, but 0 of them have been identified as habitable planets. So if I'm wrong, correct me, but if we do find one of them, if you, after this interview, your team comes to you and says, Sara, Professor, we finally found the number one, and it's packed with aliens, with real life, like aliens, just like the movies shown us. How do you think we should, first of all, disclose that information to everyone? Should we disclose that? And second of all, how should we engage? Should we even try to send a signal to them saying, hey, how are you? We're neighbors. It's cool out here in the universe, right?
Right. Well, before we get to this fun speculation, let's just rewind our mind to the beginning of our conversation, where we talked about the reported discovery of phosphine on Venus. Remember, is the signal real? Is it attributed to the right gas? If it is attributed to the right gas, does it mean there's life, or is it just a volcano or something else? So just to hit the point home, it's going to be a long time before we all agree. It might be a case where one of us finds a sign of life, but it's not believed for generations until we're all dead and people have much more sophisticated telescopes or something. So I think that's kind of a weird moment to think, because in the movies, it's always like a definitive moment. Yes, we found it. It could be just so gradual that it's almost not even really noticed. That for you, I'm going to assume that you and some listeners, the fact that there are exoplanets out there, planets around stars other than the sun, that's a fact to you. It might be something that you might not remember when it was first heralded as a huge discovery, because it was a very slow acceptance over a decade or so that people went from there are these signals, but they might not be real, to wow, they're actually exoplanets. So it may not be this like instantaneous moment that we know there's life. But all that said, I love your question. I love thinking about whether there's life there and what we would do with it. First of all, if we do find a sign of life elsewhere and they have the kind of telescopes we have or we're hoping to build, they're already going to know we're here. So we won't have to worry about do we let them know we're here? Do we send them a message? Because they're probably going to know we're here. And the first sign that we're here is likely going to be oxygen gas. It's not going to be big things like the Great Wall of China or pollution or city lights, but it's a gas that fills our atmosphere to 20% by volume. And they might even be able to guess that we're not just bacteria. They might be able to guess we're complex life because oxygen gives a lot of energy and can allow like complex life to be here. So I kind of avoided your question, really. Come on, like, wouldn't you just want to send them a message?
I would, but after I saw the Three-Body Problem, the series, I didn't read the
book. Oh, I love that. I love the book. I read the book.
I should read the book, yeah, because the series was just like, it was insane. I don't want to spoil it to our listeners who haven't seen it or read it, but after I saw the TV show, I was like, maybe we should, we have the lottery here. Should we just...
Right. Maybe we shouldn't message them, and we should think that even if they know we're here, they might not know much about us. Right. In the case of the Three-Body Problem, yeah, we don't want to spoil it, and nor can I remember whether or not they knew we were here, whether we let them know we're here. But in the case that they already know we're here, you're right. Maybe we shouldn't tell them about our planet because it's a beautiful planet.
Yes, and it goes. I don't want to go deep into the Three-Body Problem because it's such a good read and watch as well on TV that I don't want to spoil it. But it also touches on your notion that it's going to be a gradual understanding. It's going to be a gradual grasp that maybe there is life out there. They very briefly it happens like in a 200-year, 300-year basis. Everything on that TV show and the book. So I think that also brings me to the controversial, not controversial, whatever. Anyway, our listeners and previous guests, I've hosted many who think this is controversial or not. The UFO problem. Do you think that we are on that gradual aspect of it? The UFO sightings, the pictures, the pixelated pictures, the statements on Capitol Hill, in front of Congress. Do you think we're on that era of realizing that actually aliens have visited us, Professor?
No. And I want to go back to our three questions. Is the signal real? I mean, people are disputing that. But some signals do appear to be real. They're definitely something. Number two was, remember, is the signal attributed to the right gas, or in this case, the right structure? I mean, that one people aren't in agreement on. And then finally, if we agree the signal's real and it's attributed to an actual flying object, three, is it attributed to life, in this case, UFO, or is it just something else, like a new type of airplane weapon kind of thing? So none of those same three questions that I face in my world, they are really applicable to UFOs as well. And if you read the documents carefully, like the fact that the United States Congress did a study, it doesn't legitimize that it's a UFO. If you read it, they boil it down, and you'd have to look through it yourself and fact check, but it's just like the tiniest fraction, like a percent or something of all the sightings are unaccounted for into what their source is. And you could say, okay, that means there's a UFO. Or you could say, I don't know what it is. It's unaccounted for. So we can't just jump to what we want it to be. So what can we do about this? We need to get more data, better data. I do support that. That if we have a chance and a pilot or someone sees something strange going on, we need more facts, not just an image that it sounds a lot like this Phosphine thing, an image that's pixelated that we have to do something to get the signal. it's got to be more than that, more robust. It's got to have really hard like velocities or momenta or, measurements that go with it. I'm not working in this area, so I don't know the best way to do those measurements. But I'm with you and everyone else about being so intrigued. And I don't blame people for hoping that these unidentified objects are due to aliens, but I don't have any reason right now I don't have any reason to support the UFO alien idea, or that we're on the cusp of looking back. We'll say that was the first time we saw it.
Well, the only source that I have for to retrieve data is my phone, and I think that billions of others just do as well. So hopefully, I hosted Gary Nolan. He's working on the Soul Foundation, and he's working on trying to really legitimize these ideas more in terms of finding data and having that conversation.
Right. And if he finds a way that people's phones can do something more quantitative, or people could have some device they can carry that could make the measurements we need. And maybe someday our devices will be sophisticated enough to do that. So I definitely support trying to get more data that tells us what we need rather than the grainy pictures. And I'm all for someone criticizing my work and going, oh, Phosphine, we need better this, better that. We don't believe. So I know I sound like the people not believing my work, and I'm good with that.
No, this is how science burns out, with the discussion and of ideas. But it brings me to this paradox, Professor, because how is it that us on Earth, we have, this is kind of like the skeptical side of things. How is it that we have so many pictures, so much evidence, quote unquote, of UFOs, of life visiting us from the outside, where you've pretty much searched a huge chunk of the universe and haven't seen one trace of it? How can we consolidate these two ideas that, Earth, life out there, paradoxically, is on Earth, and you working on the forefront of finding life out there, you haven't seen anything?
Right. Well, we're still in our infancy of searching for life beyond Earth. And the SETI people searched for extraterrestrial intelligence by listening for signals. They will tell us that they have searched the equivalent of one glass of water compared to all of Earth's oceans. So in fact, they're not necessarily in conflict yet, because we haven't, as you said, we have maybe a couple of hundred planets in the so-called Goldilocks zone, but we don't have the tools yet to identify whether or not they are habitable or whether or not they do have signs of life. We're not there yet. So we don't really know. The other thing we have to grapple with are the vast distances between planets. Like our nearest star system is 4 light years away. And we don't have any way to get there. Our fastest spacecraft would take 70,000 years to get to the nearest star system. So another alien civilization has to be much more advanced than us, and they have to have a lot more energy at their disposal. Here we are talking about Mars, and do we want to go? It would be so hard. We need a lot of energy to leave Earth and get there and to start there. So these aliens would have to be so much more sophisticated, have more energy, more ability. And the conflict could be that there just aren't enough planets close enough that could host intelligent life. So I'm with you that there may be a conflict, but to share with you and the listeners, we're not there yet.
And my first question is, what new resources or new technological advancements does your team need, or does the whole, your whole area of research need for us to really narrow down in terms of finding life out there? Those tools that you mentioned that we're not there yet.
Right.
What are some of them?
Well, we have a lot of great tools. We have our new Hubble. It's called the James Webb Space Telescope. We have new giant ground-based telescopes coming online. One of them is called the European Extremely Large Telescope. It's going to be in Chile. But all of these will, ultimately for the short term or the near future, we're still going to be stuck on our 3 questions we keep going back to. Is the signal, tiny signal, is it real? Is it the right gas? Is it from life or volcanoes? So we ultimately will need a new generation of scientists and engineers to have much more complicated telescopes. For example, one of my favorite ideas, it's not real yet, it's not implemented or implementable yet. It's called the Solar Gravitational Lens Telescope. And it would be sending a telescope or a series of telescopes to 500 times the Earth-Sun distance. the focal length of the telescope would be 500 times the Earth's sun distance. And this telescope would use our sun. It would block out the light of our sun, but it would use our sun as a lens, a gravitational lens, because mass bends space. And if we line up this solar gravitational lens telescope with the sun, with a known target behind it, we could magnify that planet to a surface resolution of 10 square kilometers.
Wow.
So to be sure, we're talking about a whole new paradigm, just like how we went from nothing to a GPS, we have to go from our current telescopes to like this new complicated regime. And out of the ideas out there, we don't yet know which ones will work. So it's really, we can have our candidates and planets we might think there's a sign of life, but people are always going to debate it until we can go way beyond.
Wow. And so do you have like an estimation on how much time will it take us to get to that new stepping stone?
Well, right now, each of these new ideas, there's a champion behind it, someone who's, trying to raise money and solve some of the technology tall poles. But it could be a few decades before these ideas are workable. And then imagine if we could build this telescope and launch it 30 years from now. It still takes 20 years to get to its destination because 500 times the Earth's sun distance is so far. So we're about a half century away. I don't want that to dissuade anyone. Like, things take time, Things take time. And it's a multi-generational search for sure.
Wow.
But wait, let's go back to I just want to go back to Venus for a moment.
Yeah.
Because, we can find a sign of life on any planet. It's kind of a version of your conflict idea. But if we can find a sign of life on another solar system body that appears to have started on its own, it's like it wasn't seeded from Earth, that were totally independent life origin scenarios, that is what gives us hope that there is life on a nearby planet. Because if it can start twice in our solar system, it gives us hope that it's easy to start and that exoplanets that might have life are likely to have it. So in this whole idea of should we go so far away, should we take this half century or century long effort, if we can go to Venus or Mars and find signs of life here in our solar system, it definitely motivates us.
Yeah, so if I understood correctly, Professor, is that if we find that on Venus life is original from Venus, is the source is actually Venus and Earth, like they're not the same one, that brings us into the possibility of, life can spur everywhere. But on the other hand, if we find that this was stardust and we don't know the source of it, that creates a bigger problem then?
If we had the money and time to look at every solar system body, and a lot of them have water or water oceans beneath the surface, and we found no life, it would make our argument a bit harder. But it wouldn't stop us from searching.
And have you watched the movie Interstellar? You must have watched it. Do you feel that, the possibility of space-time bending and all of those theories of, how to go to the other galaxies and universes? I know I'm speculating a lot, and I apologize for that. This is a curiosity just speaking out. Do you feel that that's a possibility of, and in terms of like traveling through space differently rather than the way we think about it?
Right. I do love the movie Interstellar for sure. But the idea of us going through a wormhole, it's just a movie dream. Because if there was a wormhole nearby, which there isn't, we would just be totally destroyed. Think of like spaghetti just being ripped apart. We just couldn't handle the strong gravity in those wormholes. But what I loved about the movie was this idea that they had 3 planets. We won't spoil it in case someone hasn't seen it, but they have 3 planets, and each of them looks promising for us humans to live on. But they couldn't tell unless they went up close. And that's what I was trying to say about exoplanets. We might find a sign that it kind of looks like there might be life there, but until we have a whole new way of going, closer. Maybe not us going closer, but sending spacecraft closer. We won't know for sure. So that part about the movie I really loved. But could we find a new way to travel through space? Not through wormholes, but I never say never. Maybe one day.
Yeah. I would love that. That would be interesting. Not even interesting. It's just not, I don't even have the words. You know, it would be a whole completely different reality. But Professor, right now you mentioned the 3 planets on Interstellar. Are there any shortlist candidates that you're working currently on, that you're researching on, that maybe have the potential of, you know, becoming the first one in terms of a potentially habitable planet?
Well, everyone's favorites are planets in the TRAPPIST-1 system. TRAPPIST-1 is a cold, tiny star. Any smaller and colder, it couldn't be a star. It wouldn't be able to fuse hydrogen to have its own nuclear burning and energy. And this special star has 7 planets around it. They're all about the size of Earth. And a few of them could be the right distance from the star to be heated to the right temperature to support water, something that all of our life needs. And there's a variety of complications regarding the system, but it is our most promising one for study. So it is the most popular one so far.
And that's, I guess, hundreds of light years away, or thousands.
I can't remember how far it is. It could be dozens. Another favorite is called Proxima Centauri b. The very, very nearest star to our sun is called Proxima Centauri. It's a small red dwarf star, not as small and cold as TRAPPIST-1, but it also has a planet around it, an Earth-mass planet, that might be the right temperature for life. So I would have to say those 2 are top. TRAPPIST-1 planets, and Proxima Centauri b. Interesting.
And if do these planets, I mean, this is going to be a very silly question, and I apologize, but it's interesting that all of the planets are kind of like a sphere. Like, you know, are these planets, all of the ones you see, all of the planets throughout the exoplanets, the whole universe, are sphere-like, and do they behave not with the same laws as Earth, you know, gravity or whatever, but are they like kind of like the same species of Earth, of planets, so to say?
Well, yes and no. So yes, they're all spheres, because beyond a certain mass, above a certain mass, things are so massive they draw themselves into a sphere. So there's some small things out there like asteroids that could be potato-shaped or just like weird shapes. But yes, planets by definition will also all be spheres. But good question, because these planets are actually different from Earth. I'll call them Earth cousins instead of Earth twins. And the one way they're different is that in order to be the right temperature for life, planets around small dwarf stars, they have to be much closer to the star, because these small stars give off very little energy. And so in order for the planet to be warm enough, it's got to be close to the star. But by being that close to the star, there are giant tides. You know how we have ocean tides? But what these tides do over millions of years is they make the planet into a very special energy state where 1 day is equal to 1 year. The planet rotates 1 time for every time it orbits. And you don't have to understand that to what I'm going to understand next, but it is like the way our moon shows the same face to Earth at all times. It's a special energy state from tides acting over tens of millions of years. But what it means on these planets orbiting small red dwarf stars is that the star or the sun to those, any life there, would be in the same place in the sky at all times. So the sun wouldn't set or rise. There'd be a permanent day and a permanent night. Wow. Yeah, I mean, honestly, if there's intelligent life there, they're probably saying, hey, there are planets like Earth. It's so crazy. They have seasons. They have day and night. It makes no sense. It's terrible. But one more thing about these planets is these small M-dwarf stars, they're very magnetically active. They have spots and flares. And you know how, I don't know if you do this, but we're waiting to hear news that we might get the northern lights one night. I don't know if this news reaches you, but if you're north of a certain area or south of a certain area, you can get the northern lights. And the sky lights up with colors. And because our sun is giving off high energy particles, it bursts like in energy. And it can hit our magnetic field and create like a beautiful image. Well, that's activity. That's magnetic activity. But these other stars have so much more energy that they can cause dangerous amounts of energy to hit the planet. In some cases, they might even strip the entire atmosphere away. So in answer to your question, they're very different. We're just trying to find out how different from Earth.
And you mentioned tides, and that reminds me of one of those three planets on Interstellar. They have huge tides, like huge waves, which was very disappointing to see in the movie, but I did spoil it a bit, so apologies for all of you. Professor, as we begin to wrap up, and I would love to host you again because I have so many notes and questions, but two more questions. One is a bit, again, speculative, but I would love to hear your thoughts on it. Is, the notion of consciousness. We're conscious beings, and we can speculate on why did this happen, but do you feel that the idea that humans are conscious, does that beget the possibility of, of the existence of any universal consciousness, or, the consciousness factor, because we haven't even found the source of consciousness. So do you think, other planets or light, the stardust or whatever, just brings consciousness with itself?
I don't think so, but I share your interest in wanting to know the root cause of consciousness.
I would love to know that myself. That's my question, like for all of the for many guests. I think that my last question here, Professor, is, a lot of science is related to the being able to say, I don't know. When someone asks you, I don't know about something, you make that statement. What I don't knows you have right now in your mind that, I don't want to say keep you awake at night, but what I don't knows you really want to find the answer to?
I do have one of those, and that is, can life exist in a non-water liquid? Because all of our life needs water. But we know there are other liquids out there, not just concentrated sulfuric acid. But if life can survive in other liquids, it really opens up the chance for life throughout our galaxy and the universe.
Wow. What other liquids are there, that could, be candidates?
That's a good question. There is concentrated sulfuric acid. I'll give you one other example. On Saturn's moon Titan, it's very, very cold, and there's what's essentially gasoline. There's ethane and methane lakes. And there are probably other liquids out there as well.
That's just, it blows my mind how many chemicals are in the universe. I read once that there's a chemical that we could create an alcohol with, like a new tequila. But that's a conversation for another point in time. But Professor, thank you so much for joining me. This was really, really enlightening, and I have homework on my end in terms of so many ideas that you brought up and shared. And I know that our audience will also appreciate you being with us today. So thank you.
Thank you very much.